Hello everyone, my name is Dave Whitesley. I'm Technical Director of Envisageukltd and welcome to another of our Friday morning webcasts. The subject of this particular webcast is multi-body modelling within Inventor. I'm going to dig a bit deeper into it this time and may go over half an hour, but only just, hopefully. This is based on Inventor 2013. Those of you who have got 2013 will hopefully notice new interface and new functionality. I'm going to work entirely on multi-body modeling. I'm going to use two examples. The first one is it's an electrical arrestor for a high tension power line. It's made up of some plastic components, some aluminium parts, a ceramic disc, and also it's filled with a potting compound, so it's actually filled with a liquid plastic, a resin, and I want to model this. Now what I've got here is I've got a part file. Now all multi-body modeling is done within a single part file. This particular part file contains two sketches. I've turned the dimensions off at the moment, but you'll see I've got two sketches in two different work planes. You don't have to, you can work from one sketch should you wish. The whole idea is that I'm going to create a pseudo assembly, if you like, within this part file. So the first thing I'm going to do is, let's explain what we've got here first. I've got a steel bracket, a steel plate. These will be bolted through. I've got a ceramic disc. I've got a piece of stud here. I've got a plastic moulding that I'm going to revolve, and this area here is where the resin will be, and the line there is the height at which I want the resin to fill to. So there's quite a lot here, and to actually model this as separate parts would take a while, and obviously then you've got to assemble it together, and also if you change any sizes, what happens if with the assembly should you change sizes. Because I'm working in a single part file, all the dimensions can see each other, all the geometry can see each other, and I'm working within a single part file where all the parameters are available to me. So it's a much easier way of working with an assembly within the part file. Those of you who've used Inventor in the past, this will be alien to you. But just think of this as a part file containing a pseudo assembly. We'll worry about how it becomes an assembly later on. So let's start working on this. Let's extrude the plate first of all. So we'll just go to extrude. I'll use the old dialog box so you can see more of what's going on. And we'll take a profile here and extrude it mid-plane. I'll measure this off of the geometry I've got already. And that'll produce the extrusion for me. So that's my first part created. We'll just turn the visibility of the sketch back on again. And the next thing we'll do is create, let's revolve the ceramic disc. So we go to revolve, take the profile for the rectangle that represents this disc, an axis to do the revolve. Now if we leave it like this, as per a default in Inventor part modeling, this will actually join this rotation to the previous part. Now I actually want this to be a new solid within my part file. So within the Boolean buttons that you get on revolve and extrude, you've got a new button at the bottom now that is entitled new solid. If I click on that, what it will actually do is it will create this revolve and create a new solid body from that revolve. And if you notice in the browser, you've got a solid bodies folder that contains the solid bodies that are actually being created. I would suggest you rename these, because these will eventually become the part files within the assembly. So rename these, it'll save you a lot of time later on. Okay, so let's just carry on very quickly on these. So we want a revolve for the threaded stud. Again, remember to add it as a new solid. If you forget and do a join, you can always go back to the feature and change it to a new solid later on anyway. So you haven't got a problem there. And we're sequentially modeling, so it's listed as per normal in the browser. But you'll notice that if you go and to one of the solid bodies within the solid bodies folder and expand that particular part out, it will actually show you the features or feature that make up that particular solid body. So you can, if you want to, on large part files where you've got a lot of features in there, you can actually expand the part out and see what it's actually made of in the browser. So we'll just rename this one. And we'll move swiftly on with the others. So we're building up this multi-body model as we go. Let's just do the plastic component here. Those of you shrewd enough will notice that actually this will intersect with the stud at the moment. There's no hole in this. We'll worry about that in a minute. Again, this is a new solid body. Let's call that casing, but I'll actually turn the visibility off. We can actually, what you can do on the separate solids is turn the visibility on or off. You can also change the properties. You can't change the material properties, only the colors. The material properties you would change when you export it out as an assembly, but let's just call this black cast, something like that. Then the resin, so we'll revolve the resin. Luckily it's found the rectangle where the disc was, so we've got a little less work to do later on, but it's still going to intersect with the plate and the stud. Again, this is a new solid body, and we'll just change, we'll call that resin. And change the properties of that one as well. The only reason why I'm changing the properties, it's just a little bit easier to distinguish the parts when you're working on the on this multi-body part. You can change all this later when they become parts in their own right within assemblies. And last but not least on this, we'll do this final plate. So we'll extrude this mid-plane. We'll measure the distance from the other sketch. It's not picking it up. Oh, that's because I need to do it as a new solid body. Let's try again. There we go. Okay, so we've got all our components here. Now we need to do a bit of Boolean work on these models. So, for instance, if we take a look at the resin, this plate is interfering with the resin, the stud at the end is interfering with the resin, so we need to do a bit of work on this. Within the 3D Model tab of Inventor 2013, we need to go to the Modify part of the ribbon. This is compressed a little bit because of the resolution of my screen, but we're looking for Combine. And what Combine does, it lets you do cuts or joins or intersects between two solid bodies within your part file. So the base solid in this case is going to be the resin. I'm going to choose to cut, and I'm going to cut with a tool body, which is this plate here, and I'm going to keep that tool body. If I don't, it'll actually delete that tool body. Click on OK. It turns off the visibility of that plate or tool body to show us what's actually happening. And if I just zoom in on here, you'll notice that it's now cut out the resin. What I'll do is I'll just put a half view on here so we can see what's going on. Just pull it out slightly. Okay, and last but not least, the stud work. So we'll just go back to that, do another combine, choose cut. The base again is going to be the resin. The tool body is the stud at the end here. Keep that. Okay on that. And that's now cut out stud work. So what we can very, very quickly do here is, using the tools that we have in multi-body modeling within the single part file, we're able to cut one part from another and produce, in this case, the resin that's going to flow around the component or the components. And of course from here I can work out the volume of this so that we can get the material quantities right. So let's turn the visibility of these back on again. We'll leave the half view on at the moment. We'll just finish off this stud here. So we'll stick a chamfer on there. And a thread. Choose M6 on this one and give it a thread length of 10 millimeters. Okay, so there's our multi-body model. If I just finish off the section view, you'll notice now we've got a complete pseudo assembly. I just want to finish off by adding a hole between these plates. It's important to note that within multi-body modeling you are working on solids within this part file. So when I drill a hole, so if I just create a sketch on this plate here, I'm going to project some geometry from the back as well so that I can get the midpoint between these two overlapping plates. I'm able to project geometry from other parts within or other solids within this part file. So now I can just add a construction line between these two lines, put my point on the midplane, on the midpoint here. I know that the hole is going to be in the middle now. So when I drill my hole, what's going to happen? Well, if I drill the hole we can pick up on this point, tell it what size we want, and tell it to drill through all. Now you've got to be careful here, because when you drill through all, what's actually happening is it's only drilling through the solid body that you're sketching on. You see the solid body that's highlighted in magenta or dotted magenta line type? That hole is only drilling through that. So in the dialog boxes you will occasionally see a solids button. This enables you to select other solids within this part file, and in this case I want to select the plate at the back so that the hole is drilled through both of these plates. If you don't do that, the hole will only drill through the plate that you actually sketched on. Okay, so that's everything finished. Now we've got to get this out to an assembly, and to do that we go to Manage and Make Components. From here we select the solids from our multi-body part that are going out to the assembly. The assembly by default will take the assembly that you're actually putting these into will take the same name as the part file. So when you're creating your part file, it's a good idea to give that the same name as the assembly, or that the assembly will be given. We go to Next. What this will now do is it will give us a list of the solid bodies that you've named originally in the part file. It will give you a list then of the components that are going to be created. You'll notice it takes the solid body's name. You can edit these here should you wish. And then the templates. Now what I'm going to do here is the plates. I'm actually going to use a sheet metal template. It'll save me time later because I may want to do more work on the sheet metal when this goes out to an assembly. You can scale as well. This is quite useful if you're doing molds or anything like that where you need to scale this as it goes out to the assembly for shrinkage purposes. Click on OK. This will then create an assembly containing all the part files that we've just produced as solids within our multi-body part. Okay, so now we have our assembly. I can do further work on this. So for instance, well, first of all, let's look at the browser. You notice everything is grounded. We don't have to assemble these parts. They're assembled in relationship to the multi-body part that we created earlier. So everything's grounded. We don't have to do any work there. You can unground them if you wish and reassemble later. It's not a problem. Let's take this plate. If I edit this, because this was then created using a sheet metal template, I can actually go to the sheet metal defaults here, tell it this is actually, I think this was 2 mil thick. And then I can do further sheet metal work on here. So for instance, I could actually add some bends to this component. Return out of that. I could do the same to the other plate should I wish. Yeah, let's go ahead and do that. So we'll take that plate, edit that one, go to the sheet metal defaults. This was 2 millimeters thick as well. It's important to give this the correct sheet metal thickness if you are using sheet metal templates, because in a minute I'll explain, we'll dig a bit deeper in the properties that we're having produced by multi-body models. And then finally, a word of warning really more than anything else. These are all derived components, right? So what's actually happening to these parts is, if I just double click on one, the stud for instance, you'll notice that it's actually a derived component coming from the original multi-body part. So there's no features in this yet. You can add features later should you wish, like I have done with the bends on the sheet metal part. But they are derived components, like they are coming through from the original multi-body part. And they're associative, all these are associative to the multi-body part. So if we change the original part, all this changes as well. So a tip really first of all is, if you want to find out what the multi-body part is, and you'll look at this assembly, somebody else may have created this and look at these and think, hang on, these are all grounded. So it gives you a clue that this is actually coming from a multi-body part. If you edit one of these, it will show you then that it's actually a derived component coming from a particular part file. You can then right click on that and then you can open up that base component, and that will then send you to the original multi-body part that you can then edit and then update this afterwards. We'll look at that later. When it comes to things like bolted connections, you need to be careful because, let's just save this assembly. You need to be careful because these aren't seen as holes, because these are derived components. There's no intelligence as such when it comes to holes. So when we add bolted connections, you can't use by hole. I would suggest you use concentric. And if we then choose our start plane, the circular reference, the termination, it will then be able to produce our fastener. I'll just put one in. So really the best way of working with this is create your holes in the multi-body model and threads as well, remembering to select the solids as you go, as I showed you earlier. And then when we come to add our fasteners, when we do a bolted connection, just remember that, put the right size in here, you can't use by hole as a reference. Okay, and then put our bolted connection in. So you have to use the concentric option when you put bolted connections in. Okay, so that's our assembly. If we go back to our original part file and change this in some way, so let's go back to the original sketch. Let's change the depth of the resin. So we'll just change the value of that. So let's put the depth of the resin up another 10 millimeters. Finish the sketch. The model will then change accordingly. This is the multi-body part, so that will change accordingly. And if we go to the assembly, update the assembly, then everything's updated in this assembly. So that's the way to work with multi-body parts. What I'm going to do now is we'll have a look at another way of working. So that's working with sketches within multi-body parts initially. What we're going to do here is have a look at something that I saw the other day that might be of interest, where we were looking at creating a mold. Now this is a polyurethane component, and we've got the part file that we've designed already, and I want to stick, this is quite a large semicircular polyurethane component that we want to make a mold for. So I've got the part here initially, and what I want to do is clad this with steel work and a plate so that we can then inject the polyurethane foam within this mold. So I can work from this part file, and literally all you're doing really is working on the part. So for instance, I can sketch on this face here and perhaps put a piece of piping in here, a piece of steel pipe in, for instance, to help me produce a mold for this foam. Once I've got that sketch, I can then extrude it, extrude the profile. Again, remembering to tell it that this is a new solid. And because I can see everything else within this part file, I can now tell it to actually extrude to face at the top here, and that will create me a new solid. Just change its properties, and we work like this as we clad this assembly. Let's change its material. Okay, and we work around this component, building new solids as we go, and then eventually we're going to get to something that looks a little bit like this. So this is the multi-body part, where we've clad it with steelwork, so we've got a number of solid bodies. I haven't put the lid on yet, but this is the steelwork that you would then weld together to make the mold for this polyurethane foam component. I would have modelled the polyurethane foam part scaled already, so I may well have derived this so that I'm allowing for shrinkage. Remember, these shrink, so the mold needs to be slightly bigger. So you'd probably want to scale the part before you start working on the multi-body part. And then from this we got the assembly. Now, a word of warning here, because we're working on a single part initially, the multi-body part, I can bring the properties across, but things like length, width and thickness aren't really much use to me, because I was working on a single part, and all these components might have different thicknesses and they will have different lengths and widths. So if you wanted to put cutting lists out for your parts list, your bill of materials and parts list, it is important to actually get the information on the parts as they arrive in the assembly. Don't do all the work in the part file. So on the assembly, for instance, if we take this plate, I've already added some sketches to this plate which have created, to put the visibility of these on, that's better. I've created some sketches on this part after they've arrived in the assembly, and then if we go to the parameters, what I've done is these reference dimensions that we've added, because these parts are already designed and they're from they're derived components, the only thing you can actually do is add reference dimensions to these models. So these are actually reference dimensions. The part is driven obviously by the multi-body part, so all I can do is add reference dimensions to these. I'd also add a sketch to the side to get the thickness. Now, a tip from me, is use these parameters. G_L, capital letters for length, width for the width, and thickness with the capital T for the thickness. The reason why I do this is that if you work with sheet metal, the thickness of the sheet metal part is always thickness with the capital T. So we might as well carry on with that throughout the assembly. G_L is used for the length of steelwork. So if you use anything in the frame generator within Inventor, the length is available to you as G_L. So that's what I'm using throughout my parts in my assemblies, and I always use these parameters. It's a good tip to work with. So if I'm using sheet metal parts or steelwork or box section or anything like that, these parameters will come across automatically. In this instance, because this is a plate, the only thing really I could have used from here is thickness if I had actually made that as a sheet metal part. I didn't in this case, so I had to add a dimension, a reference dimension for the thickness. Remember to export these as well in the export column so that they become available to you not only in the eye properties as custom properties, right? They also are available to you in the bill of materials. So that when we go to the bill of materials for this assembly, these properties or parameters are coming through as G_L, width and thickness. Okay. When we then create the drawing of these parts and bring a parts list in, we can then pull across those parameters. Now what I've done in this case is I've actually created myself a parts list style, and the parts list style I've actually renamed G_L to length. But in this way, if you use G_L for the length, width will be a named parameter that you create, thickness as you would use in sheet metal, then no matter what component you bring through, whether it's box section, sheet metal part, or a component you designed, you're going to get them in the correct columns. So digging a bit deeper in Inventor, not only for multi-body modeling, this is a tip that can be used with just about anything that you work in Inventor. Use these particular parameters. So obviously the last thing we need to look at is what happens if we change a component. So let's go back to our original multi-body part, and we'll just change the sketch for this foam part. Change the dimension. We update the part. That updates the assembly. Notice how quick it updates everything. Because you've modeled in a single part file, everything updates extremely quickly. Then all you've got to do is go to the assembly and just do an update on the assembly, and that updates all the parts. So a very, very fast way of working. It's a must really if you're able to work from either single sketches or a single part file. The arrestor, for instance, was just two sketches. It could just be a single sketch. But multi-body modeling is a superb way of working. Ideas of this tooling, especially anything to do with wood, timber, excellent use of multi-body modeling. Very, very fast. You're going to get the components out a lot quicker. And of course, there's a single part file that you go to change everything. You haven't got to remember to go to various parts within an assembly to update. And most importantly, of course, within assemblies, we're not using adaptive modeling, which can slow an assembly down. This is an extremely fast way of working. So to that end, I'll finish the webcast. Thank you very much for attending, and hopefully speak to you again next week for the next one. Have a good weekend. Thank you very much.